Hello, chemistry students. Welcome back. Today we're going to be looking at how we name an ionic compound when we given a formula. You can pick this up on page 17 in your graphic organizer notes, or just add it to your spiral binder. I'm going to share my screen and let's get started. Okay, you're going to need your periodic table and your polyatomic ion worksheet. Now, our objective here is for you to be able to name an ionic compound when given the formula. And so let's review first how to determine the chemical formula for an ionic compound when you have a name. And so the first thing that's going to happen is you're going to write down the ions of each element with the charge. Remember, that is the ion, which is the elemental symbol, plus its oxidation number. Then you're going to determine how many of each ion it takes to make the compound with no charge. You're essentially balancing out that compound. You can use the crisscross to get the charges. And then you're going to write down the formula using subscripts to show how many of each ion it took on. Then you're going to reduce or simplify it if needed. So we also spent some time looking at the polyatomic ions. And remember, a polyatomic ion is an ion either positively or negatively charged, composed of two or more atoms. And a polyatomic ion is a group of atoms with an overall ionic charge. For example, ammonium is nitrogen and hydrogen, NH4, and it's a +1. Hydroxide is OH, and it's a -1. Nitrate, NO3 has a -1 charge. Nitrite, NO2 has a -1 charge. And you can use your polyatomic ion sheet to help you identify each of those polyatomic ions. But we need to now go from the formula to a name. And so first write the name of the first element, typically the metal. Of course, there's an exception. If it's a polyatomic ion, you have to use the special name of the polyatomic ion. Then write the name of the second element, usually the nonmetal, with an ending IDE. Of course, there's the exception. If it's a polyatomic ion, use the special name with no IDE ending. There's a lot of rules here. Let's take a look at an example. Na3PO4. Well, Na3, we're going to know what that is. PO4, that's a polyatomic ion because I've got Na, let me go back here, I've got Na, which we know is sodium, P is phosphorus, O is oxygen. So we're going to have to see that this is a polyatomic ion, this PO4. Another one here is MgSO4, magnesium, sulfur, and oxygen. And then we have here NH4Cl. So the Na3PO4 is sodium phosphate. We know the sodium. PO4 is phosphate, and you find that on your polyatomic ion sheet. MgSO4 is going to be magnesium, that's an easy one, and sulfate is SO4. So we're just going to take the formula and give it a name. Remember, look very carefully at the formula. If you see that special polyatomic ion, go to your polyatomic ion sheet and find it. Then we have ammonium chloride. NH4, that's ammonium, and Cl becomes chloride. So that's using that second element with an IDE ending. All right, let's take a look at this video of how to name ionic compounds easily. Take some personal notes, and this video is also posted separately on your Google Classroom in this assignment.
Howdy everyone, Mr. Kazi here with another problem of the week, and this week we're going to look at ionic compounds and how to name them. So let's get started. How would you name the following compounds? And we have 6 ionic compounds. Now I know they're ionic because it's a metal and a non-metal. So that makes them all ionic. And the thing we need to remember about ionic compounds, it's a metal and a non-metal. So let's get out our periodic table and take a look at the periodic table here. If you look at boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine, these are the semi-metals or metalloids, and they kind of separate the non-metals from the metals. To the left of them, you are more metallic, and to the right of them, you are less metallic. So you've got to get out your periodic table, and you've got to use it. It's one of your most important tools, people. You also might want to download this handout right here that I have at yourchemcoach.com. Go down to the URL at the bottom of the page. Just put that into your browser. Go and download this handout. It's on roots and prefixes. It has the most common polyatomic ions on it as well. It's a great sheet to have, and boy, I tell you, if you could talk to your teacher and you let me use that, or at least use it as a way to memorize all of this information, it's a great tool. One of the first things you want to do is write the name of the cation, and that's usually the first element, and it's the metal. Then you want to take the root of the anion and add IDE, just like oxygen. The root is ox, so add IDE and you have oxide. Then 3, check the charge of the metals. You always want to make sure you check the charges and everything's going to balance out, especially those metals that have multiple ions. They have multiple charges, like chromium. You have chromium +1, and you have chromium +3, and chromium +6. And so you have to know which ion you're talking about and balance it. And also it's where we use our Roman numerals. And use your polyatomic ion sheet. Now, the way we name these ionic compounds is different than the way we name a covalent compound. It takes a little more thinking because you've got to be sure whether or not you're going to be using a Roman numeral or one of the old names. Now, I say that you learn the new system, but you be aware of the old system. It's on the handout if you download it, those that have the old system names. All right, let's get going. To the magic blackboard. Sodium chloride. Well, first of all, it's sodium. And then notice we have a chlorine ion. And by the way, sodium is +1, chlorine is -1. And if you don't know how to do charges, you need to go and find my video on valence electrons and Lewis stat symbols and the one on oxidation numbers, and learn about how to figure out the charges. But sodium is +1, chlorine is -1. It balances, so we have sodium chloride, and you notice we add the IDE. Pretty simple and straightforward. Look at the next one, CSI, cesium, and then we have the I, which is iodide. Pretty straightforward. And both charges, cesium is a +1 and iodine is a -1, so they balance out, we're good. Calcium carbide. Well, we have calcium, and calcium has a +2 charge, so you notice we have 2 carbons there. That's good. But calcium does not have more than 1 ion, so we don't need to use Roman numerals. Just write down carbide. And remember, don't use numerical prefixes with ionic compounds. That's reserved for molecular or covalent compounds. BaCO3, barium, and CO3 is a polyatomic ion, so I look on my chart there, and it's carbonate, barium carbonate, and you need to be aware of and to recognize polyatomic ions. CaO, calcium oxide. Calcium's a +2, oxygen's a -2, so it balances out real nice, and there are no worries about the ions. Calcium has one type of ion, copper and chlorine. Now, apparently there's 2 Cl's there, there's 2 chlorines, and so then it's going to, we would say copper chloride. Most people would, but that's just not correct. And the reason that's not correct is because that's copper 2. I know it's copper 2 because the chlorine, notice the chlorine right here has 2 ions, and chlorine is a negative charge. That's a -2 over here. That means this is +2 because they have to balance. And copper can be copper 1 or copper 2. And in this case, it's copper 2 because of the charges. So then I would write copper 2 chloride. And that's how we do it. Send an email to Mr. Kazi at mrkazi.com and check out Mr. Kazi's world. There are videos and PowerPoints and much, much more.
Okay, so let's remember these polyatomic ions. There are certain common ones. The polyatomic ion is a positively or negatively charged, covalently bonded group of atoms. You've got ammonium, nitrate, hydroxide, phosphate, sulfate, carbonate, acetate, and chlorate. Those are your most common polyatomic ions. You can use that polyatomic ion sheet whenever you're working on these particular problems. Here's some practice. Let's take a couple minutes, work on that in your notes pack. And remember, don't forget to use the exception 1 for the polyatomic ions. So we want to write the name of the compounds based on the chemical formulas below. And if we just look at this carefully, we can see we have NO3, that's a polyatomic ion. SO4, that's a polyatomic ion. NH4 in parentheses, that's a polyatomic ion. PO4 in parentheses, that's a polyatomic ion. Then this last one, number 5, these are 2 polyatomic ions, NH4 and NO3. So pause the video, take some time, go through those in your practice, and then we'll pick this right back up in just a couple of minutes. All right, welcome back. Let's see how you did. NaNO3. That is sodium nitrate. Na, sodium, NO3 is nitrate. Next one is calcium. We knew the calcium, Ca, and SO4 is sulfate, so it's calcium sulfate. Here's where it's going to get kind of interesting because we've got NH4 which means there's 2 of that polyatomic ion, and 1 oxygen. And so it becomes ammonium, NH4 is ammonium, and the oxygen, you take the root and add IDE for ammonium oxide. Well, looks like we've got a little magnesium here, and it looks like it's a phosphate. So this would be magnesium phosphate. And now we have 2 polyatomic ions. I've got ammonium and a nitrate. And if you looked carefully, if you looked above, NH4, well, we had the NH4 over here on number 3, so that's ammonium. And NO3, I got NO3 down here. This is going to be ammonium nitrate. So pretty easy to do. You just have to pay attention and focus on it and make sure you use your polyatomic ion sheet. So let's review how to name the ionic compounds from a formula to a name. First, write the name of the first element, the metal. The exception, if it's a polyatomic ion, use the special name. Write the name of the second element, the nonmetal, with an IDE ending, unless, of course, it's a polyatomic ion, then use the special name with no IDE ending. And some examples, NaPO4, MgSO4, NH4Cl. And those gave us sodium phosphate. We've got our sodium, PO4 is phosphate. Mg, you got magnesium, SO4 is going to be sulfate, and NH4 and Cl, this is going to be ammonium chloride. All right, review your notes, make sure you do the practices, then open up assignment L4, naming ionic compounds, use your periodic table, use your polyatomic ion sheet, work through those on paper, and then respond to the questions. Well, that's all I have for you now. You guys work on those assignments. If you have any questions, email me. I'll be happy to help you. You guys have a great day.